The topic of this video is polar to rectangular conversion equations. When converting from a polar point, r comma theta, to a rectangular point, x comma y, you need two equations. You need one that you can plug in r and theta into and get x, and another that you can plug r and theta into and get y. When you plot a point on a rectangular plane, you can see that we are dealing with an angle and the sides of a right triangle. So you'll want to use the trigonometric equations of potentially sine, cosine, or tangent in order to find your two x and y equations. First, let's find the x equation. If you look at your graph, x is adjacent to theta and r is the hypotenuse. So you will probably want to use cosine because it includes adjacent and hypotenuse of theta. So on this graph, cosine of theta equals x over r. As we were saying before, we want an equation where we can have just x equals on one side. So we can plug in r and theta to get just x. So all we have to do from here is multiply both sides of the equation by r, and you get an equation where x is on one side and r and theta are on another. So if you're given a problem with r and theta, all you have to do is plug in those two values to this equation and you can find your x point. Let's do the same thing to find the y equation we would like to use. So if we look at the graph again, y is opposite to theta and r is still a hypotenuse, so we'll want to use sine, which is sine of theta equals the opposite over the hypotenuse. And in this specific example, the sine of theta is y over r. Now we want to do the same thing we did above here. We want y on one side, so we can plug in r and theta to get y. And all we have to do is multiply both sides of the equation by r. And you get your equation for y. So these are the two equations you'll use when you're given a polar point and you want to find the x and y to convert it to a rectangular point.
If you found this video helpful, please go ahead and hit the like button. And also, please subscribe to my channel if you haven't already. And as always, thanks for watching.